Okay, here is an inclined plane question. But the interesting thing about this is the question starts off saying, work out the two possible values for alpha, which is the angle. So we've got a box of mass 2.5 kilograms sitting on a rough slope that's inclined at an angle of alpha. The coefficient of friction between the box and the slope is 0.15. So mu is 0.15. Right, so what have we got? We've got a normal reaction, which is in the vertical plane. We've got our gravity vector, which is 2g. We've got the 10 newtons. As I always advise, let's extend that through. We know 10 newtons, and we know that this angle is alpha. Okay, by extending this vector through, it just makes it a little bit clearer what's happening and which direction it's going in. Right, so let's have a look. So first thing, as it's got friction, let's work out R first. So first step, R. Now it's not moving, it's in limiting equilibrium. So we know it's not moving in the vertical plane. So that means that R must be equal to the forces going in the other direction. R is going up. This is our perpendicular. The 10 newtons and the gravity vector are both going in the opposite direction. So R is equal to our gravity vector, which is 2.5g. Okay, and remember that this angle is the same as the angle of the inclined plane. So that's 2.5 cos of alpha, because that's the angle marked with the vertical axis. Okay, and also we've got 10 newtons, and this time the angle is marked with the horizontal, so that's 10 sine alpha. Okay, so now we are going to do the horizontal. So let's do it down the plane. So what's pulling it down the plane? Well, 2.5 g, our gravity vector, but this time it's sine alpha because the marked angle is with the vertical. Also, we're going to put friction as going down because it's acting in the opposite direction to the force that's being applied. So now we're going to do minus 10 because 10 is going up. And that's at an angle of cos alpha. And it's in limiting equilibrium, so the acceleration is 0, so the right-hand side of our equation is 0. Okay, so now what do you do? Now what we're going to do is we're going to substitute in our R. So that means we can rewrite it as 2.5g sine alpha plus mu times our R. And I'm going to take that 10 cos over to the other side. So that equal to 10 cos alpha. And now let's substitute in our R, which is 2.5g cos alpha plus 10 sine alpha. Okay, well now we'll kind of get rid of all these g's and decimals. Okay, so we get 49 over 2 sine alpha plus, we know what mu is. Mu is 0.15, so we'll substitute that in as well, include that into our coefficient. Okay, that's equal to 147 over 40 times our cos alpha plus 3 over 2 sine of alpha, and that's all equal to 10 cos of alpha. Now you can see that we've got two functions. We've got a cos function and we've got a sine function. Okay, and we need to find an angle, we need to have a single function. So what we'll do is we'll combine them and we'll turn them into tan. So let's collect all the sines together. So if we collect all the signs together, you're going to get 26 sine alpha. That's equal to 253 over 40 cos alpha. Now we know if I want it to be tan, it's going to be sine over cos. So tan of alpha equals 253 over 1040. So therefore alpha equals 13.67 degrees by using arctan to work from 253 over 1040. Right, now that's one solution. Where does the second solution come from? Well, what we're going to do is reverse the direction of the friction. Okay, because as the angle increases, the gravitational vector becomes stronger because the sine, as that angle increases, becomes a bigger multiplier. A sine, remember, sine of 0 is 0, sine of 90 is 1. So our gravity got bigger. So let's look at the other one. So again, R is not going to change. And this time for our second one, okay, we're going to go down the plane again. So again, we've got 2.5 sine of alpha. This time we're going to subtract mu r minus 10 cos of alpha, and that's equal to 0. Do the same thing, but now this is being subtracted. So now I've got 49 over 2 sine alpha, as I did before. Now I take all the negatives to the other side. Now I've got 147 over 40 cos alpha plus 3 over 2 sine alpha plus 10 cos alpha. So this time, when I put them together, I've got 23 sine alpha, because this sine over here I'm going to subtract from both sides. And that's equal to 547 over 40 cos alpha. And that gives me tan alpha, which is 547 over 920, which means that my alpha is equal to 30.7. So that's my second solution. So now to be clear, for the first solution, my gravity vector is 9.7 newtons, okay, and that's my 2.5 g times sine alpha. For my second solution, gravity equals 12.5 newtons. But now that's my 2.5 g sine of 30.7. Remember, this is limiting equilibrium. So basically gravity is increasing and it has to be offset by something. So if our friction was stopping it rolling in the direction of gravity, that means it would balance it. But again, if the gravity is smaller and therefore the resultant force is going up with the 10 newtons pushing us up, then our friction works in the opposite direction and offsets that. And both of these answers, 13.7 and 30.7, both balance our forces and leave us in limiting equilibrium. I hope that's made it a little bit clearer.